people hear about sea level rise, but not so much about land subsidence. Could we begin by explaining what exactly land subsidence is?
Land subsidence is related to sea level rise in that as the ocean rises, it floods the land. But if the land is moving downward at the same time, it magnifies the effect of sea level rise. There are several sources that cause land subsidence. Here in Hawaii, we have a number of causes for land subsidence. Natural land subsidence is related to the buildup of volcanoes, Earth's crust. The volcanic mass of the Big Island consists of 5 volcanoes, and there's a 6th one on the seafloor offshore of the south coast of the Big Island. The mass of these volcanoes is pushing down on the crust of the Pacific Plate faster than the Pacific Plate can adjust for it. And so there's a tide gauge in Hilo Harbor, for instance, that measures the rate of sea level rise there. And the rate is twice as fast as the actual amount of rising water. Half of the rate of sea level rise in Hilo is due to subsidence of the land because the mass of the volcanoes is bending the Pacific Plate downward. The other half of the rate of sea level rise on the tide gauge in Hilo is due to the actual rise of the water related to climate change. Another source of subsidence here is in the area of Mapunapuna on the island of Oahu. Mapunapuna is a filled area where we have filled in an old arm of an estuary with dirt and soil, and we've built an industrial area on top of that. The soil is compacting so that the localized rate of sea level rise in Mapunapuna is more than the actual sea level rise measured by the Honolulu tide gauge out on the coastline. So subsidence magnifies or amplifies flooding due to sea level rise.
So can you tell us a little more about how that combination make it worse for flooding on Oahu?
Sure. One of the things that climate scientists are doing are attempting to project or predict how high sea level rise will be in the future. We'd like to know how much higher it will be in the year 2050, the year 2070, the year 2100 and beyond. And we develop climate models that attempt to reproduce the causes of global sea level rise, which are thermal expansion of the ocean as the air gets warmer due to our burning of greenhouse gases. The heat that's trapped in the air is absorbed by the ocean and it thermally expands. The second leading cause of sea level rise, and this is relatively surprising and new, is the pumping of water by humans from aquifers on continents out into the ocean. We pump huge aquifers on continents to irrigate our food, our crops, and that water then flows into the ocean. The unused water flows into the ocean, and that's the second leading cause of global sea level rise. And the third leading cause is melting of ice. The Greenland ice cap, the Antarctic glaciers, and mountain glaciers around the world. So our models that project the amount of sea level rise in the future give us a global average, but in any particular location, land subsidence means that that amount of flooding is going to happen sooner.
So you're mentioning Mapunapuna, but are there other parts of Oahu who are more at risk than others? And what kind of changes the population in those areas are going to start to see in the next decades?
We see slight subsidence in Waikiki. Waikiki is a filled wetland. Prior to Western contact in the early 1800s and the late 1700s, Waikiki was a wetland. We then have added a little less than a meter, about 2 feet of fill on top of that through dredging the Alawai Canal and through dredging channels through the reef. Ala Moana Beach Park, for instance, has a channel that's dredged, and other areas. And we took the fill from those dredge projects and we put it on the old wetlands of Waikiki and Kaka'ako in an effort to raise the land and dry it out and then develop it. The fill is compacting, and so there is minor subsidence associated with Waikiki, Kaka'ako, and even Iwalei, which is on the other side of the business district of Honolulu. Chinatown and Honolulu sit on hard basalt rock, so it's not subsiding. There's been a lot of episodes of filling the land around Honolulu in order to make it more developable, and so those areas are compacting slightly. The impacts of sea level rise are numerous. As the ocean rises, it causes coastal erosion. It will accelerate coastal erosion. It causes the water table, the groundwater table underneath the land to rise. And so we get what's known as groundwater inundation. Sea level rise also causes waves to run up further on the beach. And here in Hawaii, we get large waves in the summertime coming from the south and in the wintertime coming from the north. So as the ocean rises, these waves are going to rush across the beach, and they will rush across the roads and communities that are right behind the beach. We also have drainage in our urbanized areas. We've developed our urbanized areas so that when it rains, the rain will run off a road, into a gutter, down through a grate, and into a set of pipes that will take that runoff out to the ocean. And as the ocean rises, that salt water comes up those same pipes and backflows onto the streets. This is called storm drain backflow. And of course, when it rains, if it's high tide and our drainage system is filled with salt water, there's no place for that rain to go, and that's called compound flooding.
Could you give us an example of another part of the world where this is happening and how they dealt with it, or how they're maybe still dealing with it?
Sure. Take New Orleans, Louisiana, on the US continent. Huge parts of Louisiana exist in what's known as bayou country, which is actually a giant wetland, and that's because it sits on the delta of the Mississippi River. The Mississippi River has been building this delta for tens of thousands of years. It's basically several miles of mud, and it is compacting. And the rate of sea level rise around New Orleans, which is a major port in the United States and a population center of hundreds of thousands of people, the rate of sea level rise is much higher than it is in neighboring areas that are not on the delta. The Mississippi River Delta is compacting, and so that is a form of land subsidence as well. In New Orleans, there are streets where you can stand, and the Mississippi River actually lies higher than the street. And this is because they've built levees along the Mississippi River. As the land has subsided, they've attempted to keep the river in its channel and built levees or which are really dams that run along the channels of the river. And I'll never forget standing in New Orleans and looking at a ship go by above my head. And so clearly this whole community is in a very precarious position. The graveyards, the dead are not buried in the ground because if you dig a hole in the ground, it fills up with water. The dead instead sit on the ground in cement crypts. And these are just sort of the adjustments they've had to make in order to deal with the subsidence and the sea level rise.
We are so grateful to have people like you monitoring all this. And moving back to Hawaii, how does your team actually collect the data? How does the whole process work?
That's a great question. We have an amazing team in my group, which is called the Climate Resilience Collaborative. We have meteorologists, we have geospatial analysts, we have numerical modelers, and the beginning of research mapping the impacts of sea level rise requires that you build a very granular, detailed topographic digital elevation model, or DEM. And we build our DEMs by using drones that fly over the land and take overlapping stereo photogrammetry. And when you take images that are stereo photogrammetric, you can actually create a three-dimensional surface out of them. And of course, we need to know where this surface is with regard to latitude and longitude. So as the drones fly over the land, we put benchmarks on the ground, large orange targets, and we use global positioning systems to identify the exact location of these targets. And then we build our digital elevation model on a computer, and we can orient it in space, and it gives us a vertical resolution of just a few inches. And with that, we then numerically simulate, for instance, waves. And there's a series of buoys around the state of Hawaii which have been put in place by the federal government 35 years ago. And so we take a statistical description of the wave environment in front of all the various coastlines of Hawaii, and we'll take the annual high wave and numerically run that across our digital elevation model of the reef and up the shoreline and into the digital elevation model of the community. We have cutting-edge science here at the University of Hawaii. We live in an area that has an indigenous culture with ethics and morals tied to treating the land as if it were a member of our family. And between the very best science and grounded in the indigenous values of Native Hawaii, and also living on these natural laboratories of islands that are large enough to make change difficult, but small enough to allow us to accomplish difficult change, I think we're in the ideal location anywhere in the world. And so I like to think of tourism, for instance, in the future, being community leaders coming to Hawaii to see how we did it, to see how we transitioned to clean energy, how we accommodated sea level rise, how we have continued to grow our own food despite the growing heat that we are expecting to occur, and how we've put community resilience and human values first and centered our policies around these values. So I'm very hopeful. I've located my family here, and that's the main reason why. This is, I think, the best place to be.
If you had one message you would want to share with the next generations, what would it be?
A message for the next generation: stay engaged, do not become depressed, don't give up hope. We all need to work together. We need to center our communities and center our values in everything we do. The future is one in which we are fully capable of thriving if we embrace our cultural heritage and if we embrace the science that tells us how we can adapt to the big uncertainties that are coming our way and that have already arrived, frankly.
Dr. Fletcher, thank you so much for joining us today and for sharing all your insights. And thank you all for joining us on this very special edition of EcoShow 2025, and we will see you very soon. Aloha.